right, well, you guys made it to day 3. I only made it yesterday and today. So, and sustainability, obviously an important topic. We're trying to raise more awareness in SNIA and the broader storage community. So I'm John Michael Hans. Right now I'm Senior Director of Product Planning at FADU. We do enterprise SSD controllers. This is Ari.
Yep, Ari Vanderhoeven with Seagate. And my job there is kind of being the face for sustainability and security at Seagate, and a lot of ecosystem involvement with a lot of the same groups that folks like John Geldman over here and Jonathan, or John Michael, and others are involved in.
Yeah, and so while sustainability is not in my full-time job title, Ari and I have spent a considerable amount of time in the OCP Sustainability Project. I am Secretary of Circular Drive Initiative, which is a 501c nonprofit. We'll talk a little bit about that. Ari and I and Seagate is a founding member of, and spend a lot of time talking about this stuff. One of the things we did, maybe a little over a year ago, is when OCP brought sustainability in as the 5th tenet, which was like, so there's tenets like efficiency and scalability, that are absolutely core to every single project that happens at OCP. So sustainability is now a new tenet. And when that happened, myself and the other leadership people in the OCP Sustainability Project wrote a white paper that was basically describing what sustainability means to OCP. And when people are asking about sustainability or intro to sustainability, this is what I send them. This is really the 101 guide for people in the ICT industry that aren't familiar with sustainability. And I would say 90% of the presentations I see when people talk about sustainability in the ICT industry are incorrect, and they're usually talking about energy efficiency, which is really important. Energy efficiency, when you do a life cycle assessment, is part of the use phase. And people talk about carbon footprint in the use phase, or carbon footprint of a storage device. Sometimes they're just referring to the carbon equivalent of the energy burned in the use phase. And this is a really big distinction between, and this white paper basically describes how you actually talk about energy efficiency as it pertains to an overall sustainability strategy. We're going to spend a lot of time today talking about circularity, which is its own whole category in sustainability and open OCP. And some of the things that Ari and I are trying to do is tie that to what the most important category in sustainability is this transparency, reporting, and metrics. And so in the white paper, we break down, if you're a data center, these are the things you care about. You have to report Scope 1, Scope 2, and Scope 3 emissions. Generally, Scope 2 emissions is going to be the energy that they burn in the data center that they're buying from, buying from power plant. And if you're Meta or Google or Microsoft, you can afford getting renewable energy from these big data centers, and they've largely done that. But there's Scope 3 emissions, and now Meta, as of their last sustainability report, 99% of all Meta's emissions come from Scope 3. And so a lot of the times in the past, they would just report stuff like air travel as Scope 3, but Scope 3 is the downstream and upstream emissions. So all the components that they buy, they go into their data center. That's CPUs and GPUs and SSDs and HDDs, all those components, all the carbon that went into manufacturing those devices, the hyperscaler has to take as their Scope 3. And now that it's 99% of their emissions, it's a big problem. And they're going to have a microscope on everybody, all their suppliers in the industry, and that includes us in the storage industry.
And I have to add to that, because I just got out of one of these meetings. I had to join lunch late, and it's exactly that. It's one of those really big partners. I won't mention who, but they came in to put the thumb screws to us. So if you're a storage vendor and you're not watching this stuff and you're not prepared, it's coming. And they're working on methodologies, both the companies themselves, but also through OCP and their and what's the partner we're working with again?
Oh, iMasons.
iMasons, yeah, iMasons and OCP. So
yeah, and so if you're a data center and you have to report your emissions, that kind of goes into all the categories you report there. If you're a supplier, we talk about how you do life cycle assessment, how you think about actually doing life cycle assessment, which involves actually understanding all the energy and all the manufacturing that went into the NAND and the hard drives in that case. So it's really tough. And I talked to a lot of the storage vendors, and they're like, we have thousands of SKUs, and how would we ever do this? It's not easy, but you have to start somewhere. And Seagate is going to talk about a little bit about their life cycle assessment analysis and program, which I think is definitely the best in the industry so far. So as far as what the circular economy is, again, this is some of the stuff we describe in the white paper. the priority of circular economy is just to keep goods in service as long as possible. So the obvious first strategy there is to just have use extension or life, some people call it life cycle or lifespan. And obviously us in the storage world think about that as reliability, MTBF, AFR. I think a lot of people, I see a lot of confusion around, they're like, how many years will this thing last? You're like, okay, this thing has a reliability in AFR. They're like, great, how long will it last? And we're trying to explain to them, no, it's probability distribution, and there's a whole lot of drives, and they do these testings called RDTs that are like, yeah, we don't care. How long will it last? Is it 5 years? Is it 10 years? So it's a very important topic, but at least we understand, what the average deployment term is. Most of these vendors have 5-year warranties, and that's kind of like, hyperscaler deployment is anywhere between 3 and 5 years. If you've looked at eBay recently, it's not shocking. You can find SSDs that are 10 or 12 years old, chugging along perfectly fine. So it's not like the things just magically stop working after 5 years. So this should be very obvious to everybody in this room. Reuse is the second tenet of circularity, because the way to get better use extension is if the first user doesn't want to use it anymore, they can reuse it and give it to another user. Now, as we'll talk about, the main problem in data-bearing devices is storage security, and how do you safely remove all the data and sanitize the drive before you give it to a new user. We're not going to talk too much about the other ones, sharing and repair, but the ones I will touch on is like refurbishment and remanufacturing. There's some definitions we have in there about like what exactly these are. Like, a good example of remanufacturing is like, Seagate takes a drive that's 20 terabytes and might have a platter that's not good and turn it into an 18 terabyte drive. That would be remanufacturing. Like refurbishment is basically taking a drive and maybe putting new firmware on it, flashing it, and selling it as a different category of drive. I think a lot of people think that, you to refurbish a drive, these guys just take the drive and wipe all the smart and then sell it as a new drive. You're like,
yeah. And usually it's the write head that fails.
Yeah.
So you can actually still read, but that's they call logical depop, and it's in standards.
Yeah, and so originally when we talked about this circularity problem in OCP, it was clear that OCP sustainability project had a lot to worry about. They have immersion cooling, they have data center manufacturing, where they have like concrete and the sustainability of concrete in the data centers. Like there's an insane amount of categories and of obviously the energy efficiency stuff. So we started this thing called the Circular Drive Initiative. I mentioned Seagate and Western Digital and Chia were some of the founding members, the idea is that we have an entire 501c6 nonprofit just devoted to storage sustainability and reuse of drives. And why did we think this was so important to do? Well, we after interviewing all the hyperscalers, it was clear that like over 95%, we said 90% in the white paper, but it's probably more like 95% of all the drives in the world get shredded after the first use. And Microsoft presented with me at OCP last year on this topic, and they said, like, right now it sucks. We have to shred everything, and we wish we didn't do that. Like, we don't have any way out right now. And we're going to talk about some of those paths out here today. But this is really important. So this is the CDI I mentioned is just a place where we're trying to really tie all the glue together between what's going on in IEEE, what's going on in SNIA, what's going on with OCP, and trying to pull all these things together into helping end users make reasonable policies. So beyond hyperscalers and drive vendors, we also have ITADs, so people in the industry, like your Iron Mountains and Smiths of the world, that are actually going into these data centers, like decommissioning equipment. They're the ones that have to end up sanitizing the drives. And when we talk to these guys, like, they are not experts in storage security. These guys barely know, like, they're like, we wipe the drive. We're like, you mean sanitize? We're like, yeah, we wipe them. We're like, no, it's not the same thing.
There are some who are very, very knowledgeable, and then there's some who have almost like QAnon ideas around data security and sanitization. So it's a varied group, and we could actually use more participation from them.
So, again, we're not writing standards. We're really heavily leveraging what's out there in the industry. And so for best practice for things around all things media sanitization, we're obviously pointing to the IEEE 2883 family that's happening and being developed in IEEE SysWig, the Security and Storage Working Group. As I like to mention with John, he's one of our members. All of us, graybeard cybersecurity experts, get together on Friday and talk about storage security and sanitization and cryptography. Eric Hibbert of Samsung, one of the others, members of SysWig and OCP Security Project and SNIA, is heavily invested in this ISO IEC 27040. And in that spec, one of the things that we use is a certificate of sanitization, which is really the legal documentation around how do you verify that when a drive gets sanitized, what model number it was, what serial number, who did the sanitization, what technique was used. This is actually your legal paper trail and get out of jail card. If somebody ends up suing for some kind of data breach or something, you can say, look, the technician actually used the software to sanitize the drive, and we have legal proof that that happened on that serial number and this date. So it's very important that this is a very important part of the spec that was actually reviewed by legal experts. And the next thing we'll talk about is hardware roots of trust. Obviously, the major one initiative in OCP is CLIPTRA. And then there's things called firmware audits, which OCP SAFE has now a standardized program to do firmware audits of drives. And then forensic analysis. So a lot of these companies, like these data recovery companies, will do this forensic analysis where they'll actually disassemble the drives, put the media on testers. They can do the same kind of techniques that like a nation state attacker might use if they were trying to, to recover data off a drive. So what our flow looks like today, I would say, Dell has a very similar flow to this for their, return process, and a bunch of, we talked to other OEMs, like a lot of the customers are kind of going through the same sort of process where you choose an IEEE 283 purge technique, and we have a whole IEEE 283 training up on the website if people want to know, the purge techniques are block erase, crypto erase, and overwrite. Like overwrite might be more suitable for hard drives, where a block erase and a crypto erase might be more suitable for an SSD, or crypto erase on a hard drive now too. And then obviously you need to make sure that these commands ran successfully. So that's a big part of this. And there's a lot of like vendors that will in these certifications, like Adisa is one of these companies that does these certifications for these sanitization tools. They just make sure like was the actual SAS command sent correctly? Was it sending the right command structure and stuff like that? Now on the host interface, we can do a verification, which just means we're reading the data back. And so there's obviously challenges if you do a crypto erase and all the data is ciphertext and you read some data back, you can say, okay, well, it's not the old data we think. It's actually a pretty challenging problem. On a block erase, you see there's actually a new spec going into NVMe, a new TP around post-sanitized verification, a new verification state machine. So basically, after you do a block erase, reading the data back, it's actually not a trivial thing to basically figure out, like, was the data actually erased? Was it sanitized? What is the state of the drive? So there's a lot of nuance in that. And a lot of the stuff that we're going into the specifications talk about how to do verification for different techniques, what kind of verification is adequate, how do you verify on every single drive? And after that's done, you get a certificate of sanitization. And that's really what most companies are doing today, that are like doing reuse and sanitization. Now, if you talk to some of the major hyperscalers, they would say, well, that's not enough. Like, we don't really trust the firmware on your drives. We don't know that. Like, how do we know that the crypto erase? When you said you did a crypto erase, you actually, yes, you changed the media encryption key, but how do I know that I can't harvest, the master key? How do I know that, like, if I one of the threat models that the hyperscalers described is this age-old data at rest security problem, where somebody walks into the data center, puts a drive in their pocket, and walks out. We said, well, yeah, we have Opal for that. We have data at rest security and encryption and self-encrypting drives. They said, that's great, but the key is still on the drive, and a nation-state attacker is going to figure out a way to get that key and harvest that key. And that's a really frustrating problem. And we'll talk about some of the ways that we have around to fix that. But at the end of the day, you have to, when the drive does a sanitize, you have to know for sure that the drive did what it said it was going to do. And the only way that you can do that is to, well, one, you can ask the vendor. You can say, did you validate your sanitize command? Because we can't read the over-provisioning or the bad blocks or any of the data on the drive, but you can, vendor, because you have all these software tools. So, that's one of the things that Dell does when they do the validation of sanitization is they make the vendor give you a form that says, yes, we validated sanitize, and we will guarantee that when you do a sanitize command that all the data is gone and irrecoverable. And they make the vendor sign this, like, as a legal document. Obviously Dell has, anybody who's dealt with Dell, they have lots of forms to fill out. There's obviously certifications you can do, and I've talked to a lot of people that have actually gone through a FIPS 140-3 certification, and they're like, well, at the end of the day, they ask you a lot of questions, and you could just tell them, like, yeah, this is what it does, so say what you will about that. But there are certifications on Opal and whatnot. A third-party audit, which is where we're going, is really where you need to be, where there's open source crypto modules, open source hardware roots of trust, open source firmware that does this type of media sanitization and crypto key algorithms. And we've heard from the hyperscaler, it's like they will not trust it unless it's open source and even if it's gone through these third-party audits. The next topic, firmware attestation, measurement, hardware roots of trust, is really we're going to talk about what's going on with OCP.
All right. So I see some of you attended my talk yesterday on security opportunities and challenges moving forward. And an opportunity and a challenge are the OCP implementations. And a lot of these were launched on us a year ago, caught us by surprise a little bit, because it was a small group of companies, mostly hyperscalers, who got together and decided that going through a long process in OCP of discussion with a large group was arduous and slow. And there is a risk today that standards take time, but the threat environment is moving faster than we are. And especially when you think about drives, you have to think 10, 15 years out, because the drives you ship today are going to be out there with user data on them in that time frame. So how far out are you thinking about security? It is a risk. So they introduced OCP lock is coming out next year. I haven't seen the spec yet, but I think they'll have a draft spec available later this fall. And lock is layered open source cryptographic key management. And the idea there is to make sure that the keys are not on the drive, or if they are, they're in a fuse and can be erased. So there's absolutely no idea that even in a laboratory environment, you can recover that key. And I've been told that there are companies out there like IOActive that can take a drive and scrape like a hardware root key off it. And if you don't have a pin that's off drive, then it is feasible. I don't know if they've actually done it, but it actually is feasible to recover an SED, for example, and retain the key if you don't have the proper security methods in place. So we're listening to that. We talked about SAFE already. SAFE is an auditing program, and if you go out to their GitHub and look at their review areas, there are like over 50 review areas that go through. Our position at Seagate is that SAFE is, we looked at it hard. At first, we were a little apprehensive because it's just one more requirement, because we get requirements from customers all the time. But we looked at it and we thought, gosh, this is great stuff. Really smart people, including security auditors, all contributed. The list is continuing to grow, and we just see a ton of value in it. So we're actually making an investment, and it is a considerable investment, and we're looking at different auditors. I think there are at least 8 on the list right now. And we're going to try and go ahead and see if we can produce a short form report and have a product that is SAFE certified by end of year or early next year. So we're proponents for SAFE. There is this program you see here that is part of the OCP marketplace, but really it's a customer ask, so it helps you with sales. It's simply good security practice, so it helps protect your product, and it's something you can tout as a company, so it helps your image as a company. So we're big on SAFE. Now, Calypta is an RTL change. It's an IP block that is in silicon. So that is something that we're looking at hard. It's probably a little bit further out for us to adopt it. But one thing we like about all 3 of these programs are they can promote circularity in the future, and it's hopefully one set of requirements that the whole industry can adopt. So that's our hope for these programs. I'll go ahead and move forward.
Great. Well, yeah, just the last thing I'll update is largely this was a result of us complaining about circularity in the storage industry and kind of calling out these hyperscalers for shredding all the drives, and they kind of got together a couple years ago and after me yelling at them for a long time. And
I yelled at them too. Yeah.
And again, this is interesting because it has people that are non-storage people, like from Google and Microsoft, that are like security guys that are not storage guys, look at the way storage does security, and they're like, well, we wouldn't do it this way, we would do it this way. And again, it's nice to have that perspective. One of the things I don't think is really great is that they don't really care about all the work that we did over the last 15 years on self-encrypting drives and security and sanitize Opal, they're just like, that's great. Well, we're going to do it this way. So there's probably a middle ground somewhere where there's some reasonable expectation. And I think SAFE is that middle ground where you can actually just do an audit of the firmware that exists today and the crypto algorithms that the SSD has implemented. I did talk to one of these guys at one of these at IO Active who does these security audits, and he said, on average, like he said, one of the SSD vendors they did an audit with on the first drive, one of the NVMe drives, they found like 24 critical security vulnerabilities on the drive, like the first audit. So, I mean, he's like, this is just terrifying stuff. Like, you definitely need to go to an audit, but with one of these like hardcore crypto companies that do this stuff for a living. So, so Tom, this should look familiar. Yeah, so Tom and I wrote an article in Computer Magazine it was like almost 2 years ago, I think, when IEEE came out in 2022. And it was really just about, hey, this new spec, IEEE 2883, is like redefining the way we talk about media sanitization. A lot of the same, ideas of, the NIST 888, but this article that we wrote kind of goes into the nuances of like, look, these are how the DoD, wipe and media sanitization came in, the whole 7-pass DoD stuff. You'd be blown away. A lot of people still believe in this voodoo stuff of the drives. If you just rub it a couple times and overwrite it this many. So yeah, we go into why this is such an important spec for the circular economy. Well, we've already described this today of like obviously circularity. Before you can reuse a drive, you have to make sure that the data's gone. One of the new things, and again, we have a whole IEEE 2883 training. We've done, the folks in SNIA have done a lot of those over the last, couple SDCs.
You left out the BBC article.
Oh yeah, that was pretty fun. I made it to the front page of Hacker News, and one of the things we said in the BBC article was that like in IEEE 2883, they've deprecated shred as a form of destruction because the NSA found out that if you had like a 5mm shred of a hard drive, they could actually do some forensic analysis and get data off that. And so in the article, I say something along the lines of like, yeah, crypto erase is actually more secure than shred, which if you're reading IEEE 2883, that's a valid statement. This guy on Hacker News he said, the top rated post on Hacker News was, that's bullshit. Trying to, so yeah, a lot of people just don't understand this stuff. Like they're just like, of course shredding is the only thing that's secure, but clearly that's not the case. And funny enough, I did end up talking to the guy from the NSA who wrote their spec on the 2mm shred and got some of the background on that. So it's again, NSA guys are terrifying.
Yeah, they actually have different levels. One's 0.5mm, but even then you can get an Encyclopedia Britannica off of it, or 2 or 3. Yeah.
For proper purge, a good way to look at storage and destruct is storage is a phase. Change phase.
Change. I urge you guys, if you haven't read the 2883, I wish it was free, but it's like $80 on an IEEE website. But we have a new spec. It should be done very, very soon, 2883.1, and this is really exciting. We've been working on this all year, and this is not the next version of 2883. That will be called 2883.next or 2883-2025 or whatever, whenever we end up publishing it. But this is a spec on how to recommend a practice for use of storage sanitization methods. So it's really about like, how do you think about risk and policy and the storage lifecycle and cryptography, and trying to help walk, people who are actually going to be making these decisions at major companies, like how do you walk through selecting like what type of sanitization method and technique to use. So we talk about like when is it applicable to use clear and purge and destruct, things around like sanitization when you're provisioning storage, making sure you're protecting against somebody installing malicious rootkit on the drive before they ship it, sanitizing before reuse. We actually go into like why we think purge media sanitization is very important, and the way we've defined it in IEEE 2883 is that it is protected from even like nation state level forensic auditing and like even the drive vendor should not be able to get data off the drive after a successful purge. And then, verification sanitization. Again, how do you know that the data is gone? This is the question that all the regulators need to ask because it's the most important question. We spent like almost 2 whole meetings arguing about this table. And, one of them was just, I think we had, at one point, the virtuoso was called Nightmare. we didn't think Nightmare was a very good word for spec. But the key here is that like after a purge, a proper purge, this was the likelihood of recovering data. And if you talk to your average SSD architect and you said, okay, we're going to fire off all the erase blocks on the drive, we're going to change the media encryption key, and then you could do a full pass overwrite after that, and then you could ask them like, what's the probability of recovering data? They would be like, 0. What do you mean? Like you can't. There is no data to recover. Now the problem is that in this purge, we at one point it was almost impossible, and we ended up changing it to unlikely. And the unlikely is that unlikely firmware exploit where we mentioned in a crypto erase in the case that somebody has some kind of like really nasty firmware exploit that can harvest the root keys or something like that, or there's some of the guys that do media sanitization research that come into the work group and report, and they say, I picked up this 5-year-old hard drive on eBay, and I sent the sanitize command, and I was able to recover all the data off the P list. We're like, oh, God, don't tell me this. It's really hard because, before IEEE 2883, there was NIST 888, and, some of the drive vendors, especially on the SSD side with these like $20 SSD that goes into a Chromebook. Like this is not the same level of storage security that goes into like a high-end enterprise drive that's going into a hyperscaler. So unfortunately, those bad drives are the ones that kind of bring everybody down and reduce the confidence in the entire industry. But again, it's very important that after a purge, even an expert level data recovery person, it will be almost impossible to recover any data off that drive.
Yeah, and it's been brought up like an OCP where they have a list of these SSD drives, like across 4 drives across 2 or 3 vendors that had problems with their cryptographic erase implementation, some related to BitLocker. So there are a lot of storage vendors out there. So that box is also where the OCP implementations come in, lock, Clipta, and safe. And unlikely is not good enough for government grade security. So I think you're going to talk about security levels and how to rate your data. Because this is very frustrating for us because there is an extreme, if you have to spend $100,000 to somehow physically, examine a drive in a lab and take it apart and recover data, that's only one single drive. So that is an extremely high bar, extremely unlikely. So I'd put extremely unlikely in that box, especially for cryptographic erase. But again, firmware issues and the fact that we're a very wide ecosystem of storage vendors. That's from, if you're a hyperscaler and you're looking at it from that view, it's kind of scary. So we understand where they're coming from.
Yeah, and the fun part about this spec is like I've been talking to ITADs that end up talking to end customers, and they might have like customers in the Bay Area that are like tier 2 data centers or something, and it's great. Like they're having these conversations with the customers that are like, how do you make a reasonable policy around data security and when you decommission your hardware? And this kind of table helps people think about, okay, what's the probability, this last table, like what's the probability of recovering data if it's almost impossible? And at one point we tried to say, is it 5 nines, is it 6 nines, is it 1 in 10 million drives? It's almost impossible to put a number on it. But the idea of that too is if you classify your business data and it's low risk business data or low value business data, like it's search data or it's a boot drive or something like that, then even if the magnitude of loss, if somebody recovered that data, it would be very small. And so the spec helps provide people a framework of how to create a policy around storage security and how to use IEEE 2883 to decide which purge method to use. And hint, we heavily try to urge people to use purge media sanitization instead of destroy. And destruct is really of like, look, if the drive is inoperable or you can't access the data, the drive is broken, and then that's the time where you should implement destruct and really not just blindly do it as the first step for media sanitization. So switching gears a little bit, so that was really the storage security part, which is again like the most important barrier of circularity, because if you don't solve that problem, no drives get saved. The other thing we see is that again, this is like really surprising for us in the storage industry because like we all know about SSD reliability and AFR and hyperscalers do studies and drive vendors have their own data, but you would be amazed, like the amount of like knowledge out there in the storage development, software development world about how like SSD health works. they think it's just a complete mystery. So one of the things that we did in CDI is teamed up with Seagate. They have one of their developers. They have a project called Open Chest, which they've open sourced a complete suite of tools to do this stuff like media sanitization through IEEE 283, but also can read the SMART, read the device statistics logs, parse their custom logs. So we built this software into one of our open source pieces of software that can basically do analysis and health on grading of drives. So basically you run it, it looks at all the SMART data, all the logs, and can tell you, yeah, this drive is bad, it's failed, this has 100 reallocated sectors, it failed the test, whatever.
Yeah, I mean, this is where I get frustrated talking to ITAD vendors. I've presented at one or two of the conferences you have too. And, there is, first of all, their understanding of how to grade a device is based sometimes on 10, 20 years ago. And they aren't, they look at bad sectors, like if there's a single bad sector, we graded a B. Every drive we ship has some bad sectors because, we're talking about 20, 30 terabyte drives today, or even a 10 terabyte drive. So this is where I'll use the word QAnon again, is that there are some security experts out there just have crazy ideas about how to grade a drive. So that's my view of where this can come to help. And we really need to push this in the ITAD community.
Yeah, it's going to be great. It's going to be just a little Python package. You can just do, we pip install CDI Health, and you can run this tool, and it will run either like a combination of Smart CTL, NVMe CLI, and Open Chest, and be able to basically dump telemetry on the drive. And it's going to be really, we'll have vendor plugins, so if vendors want to have custom grading or some secret sauce in there, we can do that too. This is one of the ones I presented at OCP last year, which is, for use extension, now at least the hyperscalers are thinking, okay, if the devices are reliable enough, how do we go from a 5-year to 7-year deployment? One of the key methods there is, platform and firmware resiliency. And, OCP NVMe SSD spec went a long way with, the C1 log page for error recovery. So, if you have these like 60 terabyte SSDs, you don't want a simple firmware fault to just brick the drive and be like, yep, I guess it has a firmware bug, so we bricked the 60 terabyte drive. Like, no, you need to recover that drive. And even if you have to erase the firmware and start fresh, and lose the data, that's much, much better than like failing a drive. And now all these hyperscalers are doing this, right? They're not letting a stupid firmware failure, kind of like take a drive out of the fleet. And that was great. It went and took, hyperscale AFR, like cut the AFR in half, because the last 10 years, most of the SSD failures were firmware issues. Now, what we want to get people thinking about is like even the future, like ZNS and zones, and there's lots of ways you can handle smaller failures where you can again ZNS, you can take a zone offline or take a whole die offline and just remove the zones and have the drive keep going. In the hard drive world, they have depop. So if a drive fails one platter, you don't have to just completely fail the whole drive. So anything that can keep the thing running longer, in which in the SSD world is really just like get all the firmware bugs out, which we've done collectively a much better job over the last couple of years than we did 10 years ago. There's a big push in OCP for the new telemetry page. So we talked to the folks at Meta and that kind of wrote the C0 log page, and they said it's pretty good, but it's not good enough for them to really do ML predictive failure across the entire fleet. There's still some stuff that gets through. So the new telemetry log page is designed to basically be able to accomplish that. Enough data on the drive where they can read out the data on the drive and do predictive failure at scale. And so this is really, really important of just having, obviously there's a big push in OCP for the standardized human readable telemetry. One of the things that I did with one of the ITADs in CDI in the UK, this is a company, Interact, and I wrote this paper on this health grading software that we're going to write. But they're in ITADs. They decommissioned like 100,000 drives, and they ran kind of our suite of algorithms on it to decide if a drive was good or bad. And the outcome of that study was like 87% of them were suitable for reuse. And these are drives, 6-year-old drives that they're decommissioning from totally random data centers. So this was a fun paper. I realized when I kind of wrote the intro to this paper, and I realized when we were doing this, like there's not a lot of papers, academic papers out there that just describe like really basics about how this stuff in SSDs work. Most of the time I read papers on like, this is how trim works, this is how garbage collection works. I'm like, that's not how it works. They should, oh my God. So we as an industry really need to do better at writing some of this basic stuff down. so that when we train the LLMs, they understand how SSD people think. Because if we don't write it down in an academic paper, it will never be out there for the AIs to train on.
And what's the scale of drives that we're talking about? I mean, the scale here is huge
Yeah.
for SSDs.
Yeah, I mean, SSDs now is like over 400 million units a year, right? So this is, I mean, even 117,000 drives is kind of a drop in the bucket, right? It's not that for all of us. Like, when I was at Intel, one of my product lines would ship 7 or 8 million units, right? And we knew the AFR on that drive exactly down to the hundredth of a percent. So it is us in the SSD world and hard drive world, like we know all about reliability of drives. We need to share that data with academics because they don't have anywhere to get that data besides like some random Q&R guy at one of these companies. So. And then the other really exciting paper that was for Microsoft and Carnegie Mellon, which I think Shruti is going to talk about a little bit this afternoon, was really important, right? The name of the paper is like a call for research on storage emissions, and the paper has some pretty shocking stuff in it, right? Which is that storage accounted for 33% of the operational emissions, which shouldn't be that surprising, right? If you just take like the amount of capex, the amount of power in a rack, for hard drive rack for storage versus compute racks and stuff. All right, that kind of makes sense, but 61% of the embodied carbon, the embodied emissions, in all of Azure Data Center comes from storage. I mean, that should be an astounding number to everybody in this room. Yeah, I think that's just storage. Yeah. Yeah, and you can see here, this was the average breakdown in a compute rack of SSD versus DRAM versus CPU versus other, and so in the paper, I'll have the link there in Hot Carbon to the actual link to the paper, but they have like, the compute rack and the storage rack and the emissions associated with that.
I have asked for more information on how they calculate their embodied carbon. They can't share it yet. But we had a very good conversation, and we seem to be, kind of agreeing with where they're coming from. Yeah.
And I had a conversation with this company, MakerSite, this is one of these like AI software companies that like helps people do life cycle assessments for products. But I asked them like, do you guys have like first party NAND data in there? They're like, well, no, we just have like the semi data. It's kind of like standard semiconductor manufacturing from all the different phase. So it's not perfect. So I've been trying to solve this problem of like, okay, what is the actual? There was a paper. And I think Ari's going to reference it as well, that was like the dirty secret of SSDs. And, now, while I think the paper was kind of junior and the recommendations they made were kind of silly to anybody in the SSD world, as far as like implement better garbage collection, you're like, that's not gonna help. But the one, I wish they would just have retitled the paper, because the one trend that they found that was really interesting is that the embodied carbon on an SSD scales with capacity, because most of the embodied carbon on an SSD comes from the flash itself. Yeah. So when you go from a 512 gigabyte drive to a 61 terabyte drive, you scale the embodied carbon by that order of magnitude increase in capacity. And
yeah, that may or may not true when you talk about QLC, for example. Mm-hmm. So there could be a slight flattening out. These are very small drives, like gigabyte, multi-gigabyte drives. Yeah. So getting that information on embodied carbon is very tough for us. It's even tough for some of the folks who work for these companies.
Yeah. Yeah. And that was one of the problems in the study, was they had a hard time finding life cycle assessments for SSDs, and a lot of the SSD vendors are not publishing first-party data on carbon. Now, Apple does. So in Apple's 2023 sustainability report, they have the carbon emissions from, and they call it embodied carbon for the whole life cycle assessment of a 128 gigabyte iPhone and a 256 gigabyte iPhone. Well, turns out those iPhones have the exact same BOM besides the flash. So I can do some sneaky math and find out what the actual embodied carbon per gigabyte is on that iPhone. And iPhone, they use maybe a mix of like, I think SK Hynix and Kioxia or something like that. I don't know what they use these days, but my math calculates to about 60 grams per gigabyte of flash of embodied carbon. So if you just do the math, okay, at 517 exabyte TAM in 2024, that's just SSDs. That's not phones or USB sticks or anything like that. You'd be 31 million metric tons of CO2e just from SSDs. This is astronomical. When I shared this data with people that do this carbon stuff for a living, they're like, that can't be right. Like, it seems like a reasonable approach. And they're like, that's an astronomically high number. So How do we reduce that? So this was a study that Micron did for us as part of the Circular Drive Initiative at FMS last year, and Intel made a kind of similar statement at OCP last year. They basically said that circularity and modularity can reduce embodied carbon by up to 40%. And I think Intel said 30%. We said 40 here. But it's basically coming from if you use a device for, say, 10 years instead of 5 years, you can amortize that embodied carbon, how much carbon took to manufacture that thing over a longer period. So it sounds like a pretty basic thing, right? Like if your front end manufacturing per year goes down, your raw material per year goes down. And the use, obviously, like that's not going to go down, like the energy consumption of a drive. Now, there's a lot of talk about, okay, well, if you use a 10-year-old drive, when is the energy efficiency kind of like worse off than just buying a new thing? Well, it turns out there's like academics around this sustainable computing actually have a bunch of algorithms and equations for that. So it's mostly just TCO and power-based, but we actually have a way to solve for that. We have a and Shruti is going to talk about our OCP work groups later today, which we urge you. There's a really important new work group called Carbon Accounting and Circularity, which is, okay, if the hyperscalers have all this scope 3 and they want to get rid of it, and we have this idea of circularity that can reduce embodied carbon, like how do we bridge the gap and actually say if you can reuse a drive, how do you get credit for that? How do you get say carbon credits, but the hyperscalers are using carbon avoidance programs, carbon offsets, and so there's the first kind of thing we described is like, okay, well, how do you do it today? Like if a data center, if you're Meta or Microsoft or Google and you buy an SSD, and you put it in your data center, you have to do a life cycle assessment of that, and you figure out what the embodied carbon of that thing is, and you take the whole brunt of that your first year as your scope 3 emissions. So if they sell the drive 3 years later, they don't really get any benefit from the carbon standpoint. They actually took the whole brunt of that carbon emissions up front when they bought the thing. So that kind of sucks, but that's the way it works today. And so we have this idea that I just mentioned in the last slide of like, can we amortize that across the first and second user? Can we amortize it across a number of years? And there are some ways to basically have an internal analysis of like, yes, using it's common sense. Yes, using a thing for 10 years is going to be more efficient than using it for 5 if you are looking at a per year thing, just like buying a car or something like that. If you bought a car and then just destroyed it after 5 years, that would kind of be stupid.
And we have a carbon credits paper that I need to send to you under NDA and you, Shruti, under NDA, and a few others. So we're looking at this and we're working with third parties who do this type of accounting and auditing and make sure it's something that passes regulation. So we are very much working on carbon credits as well.
Tom, question?
So something you might find interesting, there is a new IEEE standard that could be 3469, which is the environmental liability process model for accounting systems engineering, basically looking for the carbon contribution to the supply chain. I think there's some things you guys.
Yeah, that would be. I recall.
Please
Sorry.
the question.
Tom said, there is a new initiative in IEEE. Kind of looking at some of this stuff. So I'll definitely add some links when we send out the material. And
We've only got about 5 or 6 minutes left. So,
I'm going to switch over. We have Shruti is going to talk more about what we're doing in OCP there later today. So you guys better stick around.
All right. So I'll try and go quickly here, and I'm kind of moving away from circularity to another question we get asked is, how do we get to storage carbon neutrality, which is very tough. From our perspective, when we look at drives from generation to generation, the carbon footprint is pretty steady. In some ways, like embodied carbon, mostly because of better reporting, it's going down. So we can do some math on replacing a 12 terabyte drive with a 30 terabyte drive, for example. Huge savings in carbon emissions on a per terabyte basis. Power efficiency, it comes up a lot. And as we go to larger and larger and add more platters, we've seen steady increases in power efficiency, and we're working on designing for better power efficiency. So that's across the industry, that's a goal for every storage vendor. Decreasing carbon emissions per drive. The other thing here, I won't go on too long, but life cycle assessments. We've been doing these for 10 years or more, and boy, it really helps us identify where to focus. So this is looking at our, this is from our life cycle assessments. So we're looking at generation to generation, the embodied carbon per drive has been going down. And a lot of this is us pushing on our vendors to like report how much recycled material is in your aluminum and then get that audited. And so that's really pushing on our suppliers. So I wouldn't say this is absolute, this is what we can report. I think it's more flat if you look at what was really happening, but we are staying flat even as we go to higher and higher capacities. And then again, the SSD trend on the right. So, that's the difference between HDDs and SSDs, is we stay pretty flat, whereas SSDs tend to increase their embodied carbon per, as they grow in capacity. And this is just a look at our published LCA reports. We have them published for all our hard drives. We were looking at the embodied carbon on our SSDs. And the data was coming from the EcoInvent database, and we talked to the folks that we have do our audits, and we didn't have confidence. We actually took them down because we just knew the numbers were wrong based on stuff we've been talking about here today. So calls to action. I think participating more, and many of you are participating, so we love that. Get involved, and we'd like to see more variety, like more hyperscalers, more ITAD vendors, that type of thing. So I'll finish up here and we'll take questions.
Oh yeah, thanks guys. Yeah, the one thing I forgot to add on the call to action, we've been talking about potentially doing, a new twig in SNIA for sustainability, and whether we, CDI may eventually just join SNIA or something like that, or we're figuring that out, but we want to continue discussion about this in SNIA.